We live in a world increasingly reliant on wireless connectivity. From our smartphones to laptops, we depend on invisible waves carrying data at lightning speeds. These waves, forming our wireless networks, are the backbone of our digital lives. But have you ever stopped to think about how these networks are built and optimized? How do we ensure seamless connectivity in our homes, offices, and public spaces? The answer lies in the often overlooked process of wireless site surveys. These surveys are crucial for understanding, analyzing, and ultimately enhancing the performance of our wireless networks. They provide a window into the invisible world of wireless signals, allowing us to optimize their reach, strength, and reliability. Imagine you're an architect designing a house. You wouldn't just start building without a blueprint, right? You'd carefully measure the land, consider the environment, and plan the layout to ensure a functional and aesthetically pleasing home. A wireless site survey is like the blueprint for your wireless network. It's a systematic examination of a physical location to understand how wireless signals propagate and interact with the environment. Think of it as taking the pulse of your Wi-Fi. By measuring signal strength, identifying potential interference sources, and analyzing network capacity, a site survey helps create a robust and efficient wireless experience. Just like there are different tools for different jobs, there are different types of wireless site surveys, each with its own strengths and applications, tailored to meet specific needs. The three main types are: 1. Passive surveys. These surveys are like eavesdropping on existing Wi-Fi signals. They passively listen to the airwaves, collecting data on signal strength, network names, SSIDs, and channel utilization. 2. Active surveys. These surveys take a more hands-on approach. They involve injecting signals into the environment and measuring their behavior. This provides more detailed information about network performance and potential issues, such as interference and coverage gaps. 3. Predictive surveys. These surveys utilize software to simulate how a wireless network might perform in a given location. They're like virtual blueprints, allowing for optimized network design before any physical equipment is installed, saving time and resources. Imagine you're at a crowded concert. You can hear the music, the crowd cheering, and maybe even snippets of conversations. A passive wireless survey is similar. It listens to the existing Wi-Fi signals in an area without actively transmitting any data. Using specialized software and hardware, passive surveys capture information about signal strength. How strong is the Wi-Fi signal in different areas? Network names, SSIDs. What networks are available and how many devices are connected? Channel utilization. Are there too many networks using the same channel, causing congestion? This information helps identify areas with weak signals, potential sources of interference, and opportunities for optimizing channel allocation. Section 5. Active surveys, injecting signals for insights. Let's go back to our concert analogy, where the environment is dynamic and ever-changing. An active survey is like bringing your own instrument and playing a few notes to see how the sound travels and interacts with the environment, providing real-time feedback. Active surveys involve sending out test signals from a laptop or specialized device, simulating real-world conditions. By measuring how these signals propagate and are received, we gain deeper insights into various aspects of network performance. Network coverage. Does the Wi-Fi signal reach all corners of the building, ensuring no dead zones? Data rates. How fast can data be transmitted and received in different locations, and is it consistent? Latency. Is there any delay in data transmission, affecting real-time applications like video calls or online gaming? Active surveys provide a more comprehensive understanding of network performance, helping pinpoint bottlenecks and optimize configurations for seamless connectivity, ensuring a robust and efficient network. Section 6. Predictive surveys. Simulating the future of your network. Imagine being able to preview how your furniture would look in your living room before you buy it. This technology allows you to make informed decisions. Predictive wireless surveys offer a similar advantage for network design, providing a clear picture before implementation. Using advanced software and three-dimensional modeling, predictive surveys simulate how a wireless network might perform in a specific environment. By inputting factors like building layout walls, doors, and other physical structures that can affect signal strength and coverage. Building materials, concrete, drywall, and glass can impact signal propagation, influencing the network's efficiency. Network equipment, types of access points, antennas, and their placement play a crucial role in network performance. Predictive surveys provide a virtual testing ground, allowing for optimization of network components before actual deployment. Access point placement, determining the ideal locations for maximum coverage and minimal interference. Antenna selection, choosing the right antennas to direct signals effectively, ensuring robust connectivity. Capacity planning, estimating the number of users and devices the network can handle, ensuring it meets future demands. This proactive approach helps avoid costly post-installation adjustments and ensures optimal network performance from day one, making your network future-proof and reliable. Section 7. Active versus passive surveys. Choosing the right approach. Deciding between active and passive surveys depends on the specific needs and goals of the assessment. Think of it like choosing between a stethoscope and an X-ray. Both provide valuable medical information, but for different purposes. Are like stethoscopes. They don't interfere with the existing network traffic. They require less specialized equipment and time. Initial assessments, identifying interference sources, and monitoring network health. Are like X-rays. They provide in-depth information about network performance. Troubleshooting complex issues, validating network design, and optimizing configurations. Section 8. Predictive versus passive surveys. Planning for optimal performance. While both predictive and passive surveys offer valuable insights, they serve different stages of the network lifecycle. Passive surveys are like taking your car for a checkup. Reactive, they identify existing issues and areas for improvement, best for monitoring network health, troubleshooting problems, and optimizing existing infrastructure. Predictive surveys are like designing a custom car, proactive. They allow you to plan and optimize your network before implementation. Ideal for new deployments, major renovations, and ensuring optimal performance from the start. Section 9. The benefits of understanding wireless site surveys. Understanding the different types of wireless site surveys empowers us to identify and address issues that hinder speed and reliability. Ensure seamless connectivity for all users and devices. Avoid costly post-installation adjustments and downtime. Identify vulnerabilities and implement appropriate security measures. Scale and adapt the network to meet evolving needs. By investing in proper site surveys, we invest in the foundation of our digital lives, ensuring a seamless and enjoyable wireless experience. Section 10. Conclusion. Ensuring seamless connectivity. As we navigate an increasingly connected world, understanding the importance of wireless site surveys is absolutely paramount. They are the unsung heroes of our digital lives, ensuring that the invisible waves carrying our data flow smoothly and efficiently. By embracing these surveys, we can unlock the full potential of our wireless networks, creating spaces where connectivity is seamless, reliable, and truly empowering.